Okay, so good afternoon. There is some technical problem with the resource person, Dr. MG Suraj. So probably I have some problem with the mic. So in the meantime, what do I do is I try to take you some of the very fundamental aspects of image processing. Uh, Image processing and in generally the computer vision, and I like to touch upon some of the research avenues that are available in order to carry out the research work in the field of computer vision or machine pattern recognition. So is the slides are visible? Uh, so is the slides are visible? Okay, I think is the slides are visible.
Yeah, it's visible, sir.
So my audio is clear. Is my audio is clear? Is my audio is clear okay? So my audio is also clear. So thanks for your patience, but unfortunately, due to some technical reason, Dr. Suraj couldn't connect. So I just take you to some of the very fundamental aspects of computer vision, and I try to touch upon some of the research challenges that are available in the field of computer vision. But the title says it's digital image processing. But when you see, there is a lot of association that exists with respect to an image processing and the computer vision. So what are those association, and how do we really deal with or how do we really associate with the concepts of image processing and computer vision? So that is what actually we are going to discuss in the present session. So friends, at last I try to highlight some of the very interesting research avenues that can be seen in the field of computer vision or image processing, and how exactly these concepts of computer vision and image processing can be used in order to solve many of the real-time applications. Just to start with the beginning, we have can you just see the slide? Uh, what do you see with this slide? So, what do you see with this slide? What do you see with this slide? So, can you come out with any inference with this slide? Can you come out with any inference with this slide? Yeah, you can just text it in. I can see. Yeah, can you just come out with some interesting thing in this slide? Okay, okay, there is. Can you see the slide now? Yeah. Now the slides are visible.
Stop sharing for the moment. Stop presentation.
ಏನು ಇಂಟರ್ನೆಟ್ ಅಷ್ಟು ಶಿವ can you listen now?
Sir. Yes, sir.
Yeah. Okay, so can you see the slide also, right?
Yeah, it's visible.
Yeah, sir.
Okay, so sorry for the inconvenient cost. Right. So I'll be presenting for another 45 minutes. I'll be presenting some of the research challenges that are available that can taken as a problem for your PhD work, or you can advise your students to work on this particular area. Right. So particular area. So that is the research challenges in digital image processing. Probably I try to link some of the aspects of computer vision as well as the digital image processing maybe in the later stages. Right. So if you see this slide, right. So there are if you see this slide, right. So if you see this slide, I think there are so many things that you can really visualize in this slide, right. So there are so many things that you can visualize in this slide. If you see the mouse cursor, there are something that are related to the communication, and there are something that are related to the mathematics. There are something that are related to the rocket space, and there are something that is related to the windmills, right? So even though it is basically an image, but unfortunately, we cannot come to a conclusion to say that this is what the image is all about. So this is the major challenge that you are going to encounter, especially with respect to the image. No doubt, there is a very famous proverb in the English which says that one image is better than 1,000 words, but it all depends upon the individual perception, that how the individual is going to understand the content that are present in the image, right? So in that context, these images really plays a very important role, especially while doing or while solving the many uh, uh, real-time image processing tasks, or many real-time computer vision tasks. The basic fundamental differences that you are going to see with respect to the image processing and computer vision, they are both they'll go on they'll go both and hand to hand, right? So they'll go both and hand to hand. Now, is it audible?
Yes, sir.
Okay. So thank you. So I think they both go hand to hand. In case of a computer vision, probably what do we do is we try to make use of the various camera devices, right? So various camera devices, either it could be an CCTVs or CCD cameras or different types of cameras that are available, and we'll try to capture our interest through camera, and then whatever the static contents that we are going to capture through the cameras will be taken as an input for the further processing. So that is where the actual image processing starts. So before that, all the things that we are going to do is basically an computer vision, right? So it's basically in computer vision, or just we can also mention, right? So we can also mention that we'll try to pose the different sensors or the different computers and try to acquire the images, which will be in the form of an videos, right? So which will be in the form of an videos, and then we'll try to start the processing of or conversion of that images into two-dimensional representation, which is called as the image, and then we'll try to employ the image processing techniques. Right. So yes, most of the computer vision task usually starts with the fundamentals of image processing, and then the advanced techniques of image processing techniques are considered as the computer vision techniques. We'll try to see some of the things that what exactly the challenges lies, especially in the field of image processing and computer vision. Right. So rather, I'm not going to touch much upon the image processing, but I mean computer vision. But I stick on to the fundamental aspects of the image processing, where these techniques can be further used to build the advanced modules in order to solve most of the vision techniques. Right. So most of the vision techniques. Right. So if you see the slide, can you see the slide now? The second slide. Can you see the second slide now?
No, sir, I think you should move the slides.
Is this third slide is not visible?
No, sir.
Uh, Now, can you see the slide, madam?
No, sir, I think it will take time, maybe network issue.
I think there is some problem with the Google Meet, I guess, today, because I'm not really sure. It is not taking the presentation itself. I'll just stop the presentation and redo the presentation.
Yes, sir. Now it is visible.
Okay, okay.
Yeah, now we are getting it.
Okay. So if you see this, there is one very interesting thing that you can see in this slide. Can you just highlight what is that very interesting thing that is present in this slide? So please try to identify an odd object that is present in this picture. Can you find any
Yes,
odd object?
C is there.
Yeah, so C is there. So more or less, if you see this pattern, right? So if you see this pattern, all these zeros are arranged in some sequence. Probably it is arranged in the form of a matrix. Suppose if each zero is considered as a pixel, so it is almost 7 by 7 cross a number of columns, right? So it is basically a matrix format. But then there is an one entry which contains the C, right? So which contains the C. Now, if you see an human intervention, right? So especially to handle with this kind of an images, it will be a very tedious task for any human being to identify the C, because our matrix is very smaller in size. So hence we can we were able to identify that there is a presence of C. But if the size of the matrix, right, so where the matrix is responsible to represent the various pixel information, then there could be a very challenging task that you can see these kind of an odd objects present in the patterns. Right. So in the similar way, we can find the different types of an application. So this is where actually the image processing and image processing plays a very critical role to solve these kind of problems. Right. So can you see the slide now? The fourth slide, Kasturi.
Sir, still it is still, sir. With
The
respect
fourth
to,
slide. Sorry, come again, Kasturi.
sir, I can't able to see, sir.
You're not able to see the slide.
Yes, sir.
Okay. Now is it fine?
Still not yet, sir.
There is some issue. I am not really getting what is the problem with yeah, it is presenting now. Right. So there is a lot of jitter that you can that you see. Right. So now can you see, Kasturi?
Sir, mostly due to some internet slowdown, but it is getting presented, sir. But it is getting presented.
Okay.
But mostly due to some internet connection, it is getting delay, sir. Mostly.
Okay, so I think the internet bandwidth is also around 180 Mbps now it is running. So we'll just see. This is another interesting problem that where you have different, ice creams, cones that are present in this slide, but there is an one lollipop that is present here. Right? So there is an one lollipop that is present here. And in this, but it's really a hard task with these so many number of ice creams, right? So just to identify these lollipop, right? So now, can we deploy any image processing technique, right? So in order to come out with the real finding of these kind of the odd objects, right? So that is where actually the image processing plays a very important role, right? So this is the fifth slide. Can you see, Kasturi, now?
No, sir. Still, I can't able to see, sir. So I think entire screen, if you queue for view, so it will be entire screen. The option selection should be the entire screen, sir. Full screen mode.
So I think just now.
Yes, sir. We can able to see, sir.
You see next slide.
Yes, sir. The images we can able to see. Yes, sir.
Okay, now it's okay.
Yes, sir. We have all the images present.
Okay, now can you see the fifth slide now?
So it is not at mode. This
Can you see the fifth slide now?
no, sir.
Yes, sir.
This is the images of trees.
Correct.
Yes.
Okay,
Yes.
so now we'll just continue. So what can you see with this slide? So can you just come out with some interesting thing that is present in this slide?
Mostly some butterflies.
Okay, so if you see the slide, if you see this image, you see the second image, so you can see there is a butterfly. And in the first image, can you see something in the first image?
Sir, we can see a owl.
Owl, correct. That's an owl. Can you see in the third image that there is a presence of
Lizard.
Okay, so can you see in the fourth image? Can you identify something? Very interesting thing.
Look like Ganesha, but
Sorry, looks like?
Ganesha.
No. So here, here an army personnel is sitting and is seeing something through binocular. Right. So what kind of problem is this? What kind of problem is this? What kind of problem is this? So this is a problem, right? So this is a problem that where your occlusion, no, this is not an occlusion. So this is a problem that is called as camouflaging, right? So this is a problem that is called camouflaging, where occlusion, yes, it's a part of a camouflaging, but we cannot really call this problem as an occlusion. Occlusion is when one object falls above the other object, or there is an overlapping of one object over the another object, then that problem is called as an occlusion. But this is another very interesting problem that most of the image processing researchers will try to solve, and this problem is called as the problem of camouflaging. So can you come out with some very interesting techniques, right? So such that it solves to identify that there is a presence of owl, that there is a presence of butterfly, and there is a presence of lizard, and there is an army personnel sitting in the forest and trying to keep track of the enemies. Right, so this is where actually the real-time image processing plays a very important role. Now, can you see the sixth slide, Kasturi?
Sir, next slide is not visible, sir.
Can you see now?
I think you need to reshare, sir, because as it is a PDF, I think we are not able to see next slides.
Okay, okay. So every time I need to represent it.
Yes, sir.
Okay.
Yes, sir. Now it is visible.
Okay, so these are some of the very interesting problems that exist in the present literature. What are these basically? They are basically the traits, right? So they are basically the traits. So we'll call them as the biometric traits that are used to identify an human personnel, right? So for example, I think in the present trend, these biometric and biometric traits, biometric trait applications are really playing a very vital role because everybody is talking about the security. For most of the security problems, we are going to make use of these biometric traits, right? So if you see the first image, this is something that is related to a fingerprint, right? So you can see there is a pattern, there is a minutia, right? So there is a minutia, and if you really wanted to understand the more about these concepts, you need to do some basic research on understanding how these patterns will be extracted, or the fingerprint patterns will be extracted, or how these minutia points will be extracted. So this is basically a fundamental pattern recognition problem that most of the researchers can think of, right? So fingerprint. And the second one, you see there are so many number of features that exist within the face of these personnel, right? So it is even we really doesn't know that how many number of patterns are existing in these the human face, right? So there is an point number 1, 2, 3, 4, right? So can we consider this point as a unique point in order to identify that personnel, right? So there is one work that has been attempted in order to identify the triangular shape that exists between this nose node and this nose point, right? So this is treated as a nose node. So can you try a line from ear to ear, and from ear to nose tip, and from tip to the other corner, right? So where we are going to construct a triangle, and that triangle is unique, right? So and that triangle is unique, right? So now you try to see the difference or the distance between the two eyelids, right? So between the eyelids, right? So that can also be considered as a unique feature. And if you see the lip, right? So the distance between this point and this point, right? So will remain unique, and similarly this point to this point will remain unique, right? So and there are so many works that are attempted, especially to solve this kind of an problem. The most recommendable contents that you can refer from the Arun K. Ross or the Anil K. Jain, who is from Michigan State University. I know I have published many works in order to solve the different algorithms to handle the different biometric traits. So that's considered to be one of the very interesting works that they have attempted. And the third one is the signature, right? So now the trend has changed, right? So it's not only these signatures are used to identify a human personnel, but it is something else, right? So we are one step ahead, such that by taking this human signature, can we identify or can we recognize the emotions of a person, right? So can we recognize the emotions of a person? Right, so emotion recognition through signature, right? So, for example, if the person is really stressed, probably the stress that they are going to impose on the pen or the pad will be huge, right? So then obviously the number of pixels that it is going to take will be more, right? So then can you come out with any conclusion to say that the person is under stress, or the person is in happy mood, or the person is angry mode, or the person is in sad mode, right? So there are so many number of emotions that you can think of in taking the signature of an person, right? So this this is the present trend that is going on, especially with the signature analysis. And the fourth one is the very interesting, right? So you can find a very good number of papers that are available, especially to solve the iris recognition, right? So, but people are not really interested in solving the biometric applications or building the biometric applications by making use of the iris, but people are more interested in something else, because the iris has got its own limitation, because you need to have an a very sophisticated device which helps in capturing the iris, right? So which helps in capturing the iris. So there is an intervention of an human being in order to capture the iris, right? So yes, in order to avoid this human intervention, right? So just try to capture the eyes of a person, right? So either through CCTV or through some conventional cameras, right? So then you go for the extraction of an sclera patterns, right? So the sclera pattern is basically the white region that is present inside the eye. So sclera vein patterns are considered, and this vein patterns remains unique for a person to person, and even these vein patterns are unique between an eye to eye. That is, the left eye vein pattern is entirely different from the right eye vein pattern. So that's the interestingness of the sclera vein pattern, right? So you can really consider this can be a very good problem to solve in the further days. And many of the interesting works that are reported, especially by Abhijit Das and his team, right? So they every year they'll conduct an computation, right? So which is called as an sclera segmentation and recognition computations, right? So where the different sets of algorithms are released for the different sets of sclera patterns, right? So sclera vein patterns, and they have proposed a very good number of algorithms which gives an higher efficiency when compared to the iris. So this is another very interesting problem that you can really work on. And the fifth one is something called what is this? Can anyone tell? It's basically once again an vein pattern analysis, but it is a palm vein, right? So basically it is an palm vein. This is also a very interesting problem to work on, right? So for the in the area of biometrics, and the last one is called as the gait recognition. The walking style of an personal is also an unique in nature, right? So it's unique in nature. So there are various geometrical models that are proposed in order to do this task, right? So in order to do this task, so you are supposed to come out with various geometrical features to identify how the person walks from one place to another place. So these are the individual traits that are considered in order to solve the biometric problem. But the problem is entirely different now, because people or the researchers are not happy with the individual biometric trait, but they are more interested in combining one or more biometrics, right? So that is called as an the multimodal biometrics are incorporating two or more biometrics in order to give the accuracy for the person identification, right? So that is what actually the researchers are working on. A good example is probably you can go with the fingerprint recognition with the sclera vein, and then you can go with the combination of a sclera vein with the human signature, or you can go with the face and the fingerprint. And I think if you see, the most widely used application is your other application. They'll take this fingerprint, they'll take this iris, and they'll take this signature. All three put together, which are very unique in nature, used to identify an individual. So this is how actually the image processing application plays a very, very important role. That is what actually explained. Kasturi, can you see the seventh slide?
So you need to present, sir. Next slide.
Okay, I need to. Okay. So now. So this is the next slide that I wanted to present. So if you see this face and the palm, so there is a lot of geometry, right? So there is a lot of geometry that exists, right? So try to capture that geometry and try to identify the human person in a better way. So this is where this is called as a multimodal biometrics, and try to combine the different traits like face goes with the voice and voice goes with the eyes, right? So all three are considered as the individual trait, but in this problem, we try to combine, right? So we try to combine the face versus eyes versus voice, right? So which gives the better identification of an human person. So similarly, the third image, if you see, there is and facial recognition, problem of facial recognition, there is a problem of voice verification, and there is a fingerprint identification, and there is an iris recognition, right? So there is an iris recognition, right? So so these are some of the most widely used application in the field of biometric. Just going to the next application. Kasturi, can you see now the eighth slide?
Yes, sir.
Okay. So these are some of the other works that you can really think of, where medical image analysis is really playing a very important role in the present day scenario. I think yesterday Professor Aradhya also discussed some of the lungs images which are taken as an X-ray just to make sure that there is an existence of an traces, right? So that is the virus traces present in the lungs, right? So present in the lungs, right? So they are basically the X-ray images, but there are advanced way of acquiring the different sets of an images that are present. It could be an brain images, lungs images, and pancreas images, right? So where they are going to use the modality of MRI, right? So modality of an MRI, and there are the various X-ray images that are present, right? So there are various X-ray images that are present, so which are helpful in order to identify whether there is any breakage, right? So they are so sophisticated such that even there is a small hairline crack, right? So that can be well identified through these images, right? So through these images, right? So which are called as an X-ray images, right? So then you have the other images like CT scan, right? So computer tomography scanned images, right? So which are used to scan the abdomen, which is most widely used, right? So which is most widely used, right? So you can identify the level of the liquid that is present, right? So the level of liquid that is present, you can identify the level of the metabolism that is taking place with the different organs, like it could be an liver, or could be an pancreas, or it could be an a large intestine or small intestine, or even urinary bladder, right? So the multiple organs can be visualized, right? So multiple organs can be visualized through this kind of an scan. So then you have PET scan, right? So PET scan, which is most widely used for the liver, right? So which is most widely used for liver. I just presented the different modalities of capturing the images, right? So different modalities of capturing the images and try to do the analysis, right? So they are so sophisticated such that the doctors should be in a position just by seeing these images, does it help out, right? So to take a decision whether they are, they are dealing with the good cells, or there is a presence of bad cell in the in the organ that they are looking for, right? So that's the very interesting thing that you can work on, right? So these are some of the applications, especially in the field of medical image analysis. Kasturi, can you see the 9th slide?
Yes, sir. Yes, sir. Yes, sir.
Okay, now you can see the 9th slide, right? So in the 9th slide, so can you see?
Now,
So these are,
I think now you represent. I think now it went, sir.
okay. I'll just. So, so these are some of the other very interesting applications. So, which was discussed extensively, like self-driving car, where Dr. Nagesh discussed about the self-driving car, and identifying the source and the destination by making use of the GPS, right? So GPS tracking system, right? So GPS tracking system, right? So does lot of image processing activities at the back end, and tells which could be the best path that has to be chosen depending upon the traffic density and depending upon the movement of the pedestrians, or if any uneven activities that are taking place over the street. So forensic investigation, yes, there are many applications that you can find, especially in the area of forensic and forensic application. You can think of working in this direction. And document analysis, this is another very interesting area that you can work on: document image processing and document image analysis, right? So where you need to deploy an highly sophisticated OCR models, right? So that fits between the input and the output, such that if you give an handwritten document, the handwritten document will be converted into some form of an can be converted into some form of an printed material, and can be further taken into an analysis. And this is an most interesting work that many of us done as a fundamental work, like number plate recognition. And the last application is something which is very interesting, like CCTV surveillances, right? So surveillances of uneven activities that takes place in an constrained environment, but the constrained environment is gone, right? So now people are talking something about the unconstrained, where you are not going to keep any restricted environment for any personnel to do on any kind of an activities within the region. A good example could be an personal movement in the airport, the personal movement in the railway station, the personal movement in the bus station, right? So there we are not going to keep any kind of an any kind of an constraint, but still we does or still we try to identify whether it's a normal behavior of a person, or whether it's an abnormal behavior of a person, right? So these are all some of the very interesting applications of image processing that you can or we can think of, or we can work on, right? So can you see now the slide number 10, Kasturi?
Yes, sir. Yes, sir. Continuously, we can able to see, sir.
This is an hot cake. This is an present hot cake of in the field of image processing and the computer vision, right? So where we are trying to deploy the various computer vision and image processing techniques in the field of agriculture. Right, so in the field of agriculture, because I think you might have seen the survey where in the survey, I think more than 60% of people in India, the population in India are highly dependent on this, that is on the agriculture. Right, so there was a big debate yesterday and day before yesterday. Right, so because of this, bill that was passed in the parliament. Right, so which really, where this kind of a technology can really beneficial for the farmers. Right, so who spend maximum time in order to cultivate their crops. Right, so it so happens that they are not really in a good position to identify whether the crop is infected with any kind of an any kind of an worms or any kind of an fungals, right? So whether the it's the right time to really harvest the fruits or the any kind of an grains that they are going to grow, right? So our the very interesting application is how to really eliminate the third party in order to deal with their their agricultural output directly to an market, right? So this is one of the very interesting work that you can really plan in the future coming days. And government of India is really pushing a lot of money towards this application, right? So and it's so simple to get any project to get acceptable if your proposal, especially on this area, right? So there are very interesting applications that you can really work on. For example, it could be on sorting of fruits, where you have the set of fruits that are available. Try to sort out depending upon the different sets of features. Then grading of the fruit quality. So try to measure the temperature or the humidity by making use of the sensors. And there is a very interesting field that is available called as precision agriculture and weed recognition, whether it is a right plant or whether it is a weed plant, right? So weed recognition, you can make use of computer vision techniques. And plant species identification, this plays a very, very interesting role, especially if you are dealing with the Ayurvedic plants in the forest region, right? So you're supposed to identify the Ayurvedic plant which helps in preparation of an Ayurvedic medicine, right? So we need to categorize the unwanted plant species with respect to an Ayurvedic plant species. So identify it and then try to classify it. And GPS really plays a very, very important role to does so many things, and disease identification, right? So these are some of the very interesting challenges and the important domains that you can work on, especially in the field of the agricultural science. Right. So why do we need basically an image processing? Because you cannot really, the main objective of using the image processing is to manipulate the image, right? So to an aesthetic standard or to support a preferred reality, right? So you just try to make your machine to understand that what exactly our human eyes are looking for, right? So if it is possible to identify and disease of a plant through human eyes, right? So now the question is it possible for a machine, right? So is it possible for a machine to identify that there is a disease that exists within that plant species, right? So that is why you need to have an image processing. But it's not as simple that we are speaking, right? So it really requires a lot of mathematics, a lot of physics, and lots of machine learning approaches at the back end. Why this? It's playing a very important role in the right. So why it is really playing an very important role, especially in the present scenario, because of the following things, right? So there is a revolution in the semiconductor industry because every farmer has got an potential set of smartphones available, right? So they can just go and capture either the video or the images of an plant species, and they can go to and They can go to an one center, right? So at the taluk level or at the district level, and then they can take a decision. It's not only with respect to an agriculture, that is true even with respect to an medical industry, right? So where they can just take the snapshot, or they can record that what exactly is happening to a patient, right? So and then they can go to a PHC, that is primary healthcare center, and they can take the advices, right? So cheaper cameras, yes, because hardly if you spend 4 to 5,000 rupees, right? So you'll be having a very good cameras that are a good resolution, right? So CCTVs, right? So everybody is and all government offices, government sectors, public sectors, right? So are insisting to go with the CCTVs, which is very cheaper because of the revolution in the semiconductor industry. And the drones, I think future you'll be seeing that there is no personal or human being is going to deliver some products which are ordered either through the Amazon or through the Flipkart, right? So everything will be taken care by the drones, right? So they'll try to capture, they'll try to pick up the ordered things at the storage, right? So are the warehouse, and then the drones are sufficient enough to deliver to the end destination. And extensive storage is because of the availability of the cloud storage, right? So where people are not really bothered about the storage, and the storage is the memory is so cheaper. I think you can that is available. The huge extensive memory is available at very low cost. And bandwidth, yes, to the certain extent, bandwidth really plays a very important role, but almost the world is moving towards the fifth generation network. Probably, the problem that we are seeing, especially in the area of computer networks or internet domain, the availability of bandwidth wouldn't be a much problem in the coming days, right? So and then accessibility of smart devices, right? So now if you see during this pandemic devices, right? So we are sitting at one place and we are doing so many things, right? So for example, you are attending FDP, right? So participants are there from Jammu and Kashmir to Tamil Nadu, and similarly from Assam to Gujarat to Rajasthan, right? So you see, we are just connected, right? So by using the smart devices, right? So either it could be and your what do you say, your smartphone or your laptops or whatever it is, right? Or whatever it is, right? So and all these are possible because of the tremendous research growth in the very interesting domain that is image and video analytics, right? So image and video analytics. Right, so this is the basic difference. This is the basic difference that you can find between the image processing and computer vision. I don't want to touch upon the much in detail, especially the concepts of image processing and computer vision, but you need to really understand the third very important point. So that is the image processing is a subset of computer vision, whereas the computer vision is a superset, right? So the computer vision is an superset, and whatever the image processing that you do, right? So before image processing, we does computer vision, right? So we does computer vision. We try to capture either the videos or the images, and then that images or the videos are converted according to our requirement or according to the domain, right? So and then we does the processing techniques, right? So that's the difference between the image processing and the computer vision techniques. Image processing always deals with how exactly when you give the representation for an image, how exactly your machines are going to deal with the first difference. And the difference with respect to the computer vision is how exactly your human visual system are going to visualize, right? So are going to visualize that what exactly that human being is seeing. It's as simple as how exactly our human brain thinks in looking at the different scenes that come across in front of his eye. eyes, right? So that is how actually the basic fundamental difference that you are going to see with respect to an image processing and computer vision, right? So another very interesting difference that you can see with respect to an image processing and computer vision. In case of an image processing, basically the research area concerns with more of the electrical engineering and the signal processing, because image is considered as a signal. It is two-dimensional signal, right? So I have an x coordinate and the y coordinate, which is projected over the Cartesian space, and then we'll try to make use of the spatial information of the objects that are present in the image, right? So whereas in case of in computer vision, basically we try to work on the advanced research areas like computer science and the machine learning, right? So are the machine learning. And then we try to concentrate more on the syntax and the low-level architectures in the field of image processing. Whereas in case of a computer vision, we'll try to think of giving the descriptions that whatever we are going to visualize, right? So the description based upon the semanticity, the description based upon the symbolic or how exactly that object looks like, right? So the description based upon the geometrical features, right? So the geometrical features. So this is the very interesting. The third difference is a very interesting difference that you are going to see. See, you will give an image in case of an image processing, and the output that you are going to get will be an image. Whereas in case of an computer vision, you will give an image, and what are these? Can anyone tell what are these? Chairs, faces, and car. What are these? Can anyone tell? Right.
Objects, sir.
Can anyone tell what are these? They are not objects. They are objects. But more technically, what do you call in the domain of computer vision? Chairs, faces, car. They are objects, but objects are labeled, right? So these are called the labeled, right? So the chairs, this is a label, right? So this is a label of an object, chairs, and faces, right? So this is a label of a person face, and car, right? So this is a label, right? So of the different types of an car, right? So of the different types of an car, right? So this is the difference between that you are going to see with respect to the image processing and the computer vision, right? So image to image in case of an image processing. In case of a computer vision, you will give an image, right? So it does a lot of image processing activities because image processing is a subset of a computer vision, right? So it's a subset of a computer vision, and then you will try to arrive at the labels where in turn the labels are responsible to identify the different sets of objects, right? So there are three important things that you need to really differentiate, right? So the three important things that you need to really differentiate, which almost we being an researchers should be very clear in differentiating these three terminologies. One is computer graphics, the second one is the computer photography, and the third one is the computer vision, right? So you see computer graphics, right? So where in case of in computer graphics, we'll try to give the models, right? So where those models are used to convert into an image, right? So are used to convert to an image. For example, you take a face recognition problem, right? So you try to model the face, right? So you try to model the face by making use of the different geometrical features, and then you try to construct a face by using those geometrical features. So that is basically an computer graphics. Whereas in case of computer photography, right, so you'll give an input as an image and you'll get an output as an image where you are going to do some changes for the image that you are going to handle, right? So that you are going to handle, right? So if you see this, right? So if you see this, there is an one image, right? So there is an one image, right? So there is an one image which is more clear, but you see the output of an image, it is not more clear, right? So you does some image processing activity over this original image, and you try to arrive at this, right? So you give an image, you does some processing for that image, and you'll arrive at the output image, right? So that is basically a computer photography. And lastly, you have computer vision, right? So where you'll be having an images, right? So can you convert that images into a model? For example, if you see that there is a person walking over the street, right? So there is a person walking over the street, right? So now my objective is to try to identify the different images that are present in the street, right? So and then try to label them, right? So try to label them. So that is basically a computer vision. For example, a person is going there, right? So can you identify that there is an human being? That there is a signal light here. Can you identify that there is a signal light? Right. So there is a tree here. Right. So can you identify that image as an tree? Right. So where image is given as an input, right? So and then model it and then try to arrive at the label. Right. So why the computer vision is really a very challenging task is because of the reason computer vision most probably deals with assigning or allocating a label for the end task. Right. So since we are supposed to assign a label for the end objects, that is a challenging task because the label could varies from person to person and from individual to individual and from domain to domain. So that's the very challenging task that you are going to see with respect to an computer vision. Right. So why is image processing is so hard? Because of this reason. Because our computer machines are not really, are good enough to understand that what exactly we are going to see, through our human eyes. Right. So this is what actually we are going to see. Right. So this is what actually we are going to see, and this is what the computers are going to see. Right. So this is what the computers are going to see. Right. So where the images are converted into some numerical form. Right. So our numerical form. Right. So our numerical form. Right. So that is why this image processing is considered to be a very hard task. Right. So while doing this, there could be some problem that you are going to encounter. Right. So probably there will be a loss of information. Right. So probably there will be a loss of information, and probably there could be a noise also. Right. So while acquiring the images, right. So there could be an presence of noise or the outliers. There is a difference between a noise and the outlier. You please try to differentiate between the noise and the outlier, and you need to interpret the interpretation is needed in order to understand what exactly we are seeing, right? So through our human visuals, or what exactly the computers are seeing, right? So that is why the image processing is considered to be as a very hard problem, even still today, unless otherwise. So this is basically called as the representation stage. Right. So unless otherwise, if you don't really come out with a very good representation for the image, such that the representation is very simpler to that can be understandable by the machine, I doubt whether you can really achieve the better result. Right. So this is the simplest form of the image that can be formulated mathematically. Right. So basically, it is the combination of the two important science. One is the physics, and the second one is the geometry. Right. So one is the physics, and the second one is geometry. Right. So illumination and the reflectance basically, deals with the physics, and the geometry deals with how exactly the image plane, is projected over the point in the scene. Right. So it is simply it goes like this. That is f of x comma y is equal to the function of illumination. Right. So function of an illumination, and the second one is the function of the reflectance. Right. So the function of reflectance, and where x and y are the points that you can consider over any space. Right. So if you don't define any space, so simply it will become a Cartesian space. Right. So simply it will become a Cartesian space. Then try to look for whether you need to have a conversion of this point from one space to another space. I'll just skip all these things because they are considered to be very fundamentals, right? So very fundamentals. I think most of you might have already done with these things, right? So the binary images. So this is how actually the binary images looks like. So if you just pick up only this part, right? So if you just pick up only this part, there are so many number of information that you are going to get. So that is where the challenge lies. Right, so color images, basically they are the combination of three colors, that is the red, green, and the blue. Right, so the red, green, and the blue. And if you go with the combination of multiple, multiple colors, right? So you are, you can result in the different sets of colors. Right, so this is how actually the images are sliced. Right, so by considering the multiple number of bits, right? So by considering the multiple number of bits, right? So see, there is no clarity with dealing with only one bit, right? So there is a little clarity if you go with the 2 bits. There is more clarity with 8 bits, and the true color lies with the 24 bits, right? So, but it's not simple to deal with the 24 bits. And it's also not simple to deal with the 1 bit, because if you see 1 bit information, we are not going to get any information here, right? So any much information here. But if you see 24 bits, right? So you have huge information that is available, but huge information sometimes makes to take the decision a little harder, because there are water droplets that are present at the background. There are some other information that are available, right? So which we are not really interested, right? So, but we need to clearly define whether I need to work at 1 bit level, or whether I need to work at 2 bit level, or even though I am ready to go with highly computational highly computational issues, but still these 24 bits are really serving my purpose, right? So this is where actually you need to take a call, right? So especially if you take an example of the medical image analysis, I think the doctors will be more or less, they'll be working at this level, because the more the clarity, right? So the more the clarity, the better the decision that they can take on, right? So the better the decisions that they can take on, right? So I'll just simply skip all these things, and this is a very important thing that you need to really understand. The general block diagram of and the basic image processing task, which is very well known to everyone. You try to acquire the data, then you are supposed to eliminate the unwanted information that is present in the data by making use of the concept of pre-processing. Right. So then once pre-processing is done, try to look for the better features that are used to define that particular data. So probably, you are supposed to define what could be the best features that are suited in order to deal with that particular type of data. So that concept is called as a feature extraction, and then you have an feature selection. Right, so feature extraction is always followed by feature selection, but it is not a mandatory task, right? So, but it is not a mandatory task. Depending upon your requirement, you can take a call whether to go for the selection task, or whether to go for or not to go for the selection task, right? So once the feature selection, this feature selection is basically a subset of a feature extraction. Once you are done with that, then you are supposed to give a machine readable format. So that stage is called as a representation, because your machine is in a position to understand only the mathematical representation, but it is not in a position to understand any vague information that what we are going to visualize as normal human being. Then there are different tasks to be done, like segmentation, like extraction, the correlation, the classification, the clustering, identification, right? So there are so many things that you can really work on, right? So, and lastly, this is a very important thing, that is the evaluation, the validation. Once you are going to achieve with the results, right? So you are supposed to have a benchmark results to map your results with the contemporary, whether your algorithms or the designs that you have done, right? So are meeting the end expectation, are meeting the benchmark expectation, right? So that is done at the last stage, that is an evaluation stage or the validation stage. And lastly, you have something called the post-processing, right? So where this is an optional. Suppose if you are not happy with the end result, can you tweak the results that you are going to do, that you are going to get by making use of some very interesting, by deploying some very interesting methods, so that the results will improve from to the certain level. I cannot say it's a marginal improvement, right? So, but it could be a slight jump from the small accuracy to the little small accuracy value. Right. So I just try to mention some of the very challenging tasks, image acquisition problems. These are some of the. I take another 5 minutes to conclude this session because we started late. It is almost at 12:30. I'll take another 5 minutes and wind up this session. Is it okay with that? Is it okay with that? Okay.
Yes, sir.
Okay. So motion blur, defocus, geometric distortion, DQE. Right. So these are some of the challenges that you are going to see with respect to the image acquisition. Right. So right. So you have some problem with the geometric distortion, and see there is a presence of noise here. Right. So there is a presence of noise here, and defocus. Right. So this plays a very, very important role, especially in the designing of an autonomous cars. Whenever there is an the rainfall, automatically the wipers should switch on, right? So such that the defocus has to be eliminated to the best extent. And then there is a blurred image, right? So can you eliminate that blurriness, right? So that can you eliminate that blurriness? And then you have something called spatial resolution, right? So where it really plays a very vital role, especially if you are dealing with the satellite images, and you have something called contrasting, right? So, but here also see the challenge that you are going to see during the acquisition. Even if there is a low contrast, you will be having a problem. If there is an high contrast, you will be having a problem. But you should really result in the balanced, resolution, right? So that really solves your problem. Right. So some of the most widely, important pre-processing techniques that are available in the literature, like binarization, conversion of color images into an grayscale images, right? So filtering techniques, right? So histogram equalization, right? So there are morphological operation, right? So if you see morphological operation, right? So and if you refer on any of the very standard textbooks by Milan Sonka or Rafael Gonzalez, right? So you have in one exclusive chapter to deal with the morphological operations, right? So you can make use of these pre-processing techniques. And then you have the image segmentation, where the segmentation plays a very, very vital role, especially in order to take the decision in the field of medical image analysis, where the segmentations are responsible to pick the best region of interest according to the end user. Right. So feature extraction, these are some of the features that you can think of. Right. So low level feature, the curvature features, and the image motions, right? So and the image motions, and the other feature extraction methods that are available are shape based. I think yesterday Professor Nagendra Swami discussed some of the shape based feature techniques that were available, and our transformation technique, right? So even though it is considered to be pretty old, but still it has got its own potential to work, especially on the arbitrary shapes, right? So it is really a tough task that to come out with a generalized off transformation technique. So you can really work on that, and especially if you are dealing with the shapes, you have very flexible methods like deformal or parameterized shapes, and active contours, which are considered as an snakes. Right. So some of the mathematical representation methods that are available in order to enhance the image. A good example that I gave is the contrast enhancement technique. So these are all the different methods that you can really work on. But one or the other way, these mathematical representations are basically designed to come out with some sorts of an function. Right. So, for example, that function is responsible to deal with the required information, right? So, for example, noise removal using a Wiener filter, right? So here we are supposed to define and filter or design and filter, and by designing this filter, we are supposed to come out with a mechanism, right? So where that function is responsible to eliminate the noise, right? So eliminate the noise. So these are the different. They're all basically based upon the mathematical representation. And you can also plan to work on giving the various mathematical representation to deal with the exposure, right? So, and then you have a membership function, right? So there are so many number of membership functions, because membership functions are the one which are responsible to convert one form of an image to another form of an image. You have various functions that exist in the literature, like piecewise linear function, Gaussian distribution function, quadratic polynomial curves, cubic polynomial curves, sigmoid curves, etc. But they are all based upon the mathematical representation methods, right? So this is what actually yesterday Dr. Nagendra Swami was discussing about the existence of an ambiguity or the vagueness, right? So the existence of an ambiguity or the vagueness, which can be eliminated by through some form of emphasification, right? So fuzzification can be represented in the various forms. Could be either triangular, or could be in the form of a trapezoidal, or could be in the form of a singleton, or in the form of a Gaussian, or in the form of a piecewise linear. But ultimately, these are all require some or the other form of a mathematical representations. And this is the present trend that is going on in the present day research, right? So no doubt we have a very extensive literature that are available with respect to the acquisition, with respect to the pre-processing techniques, and with respect to the various mathematical representation methods that are available. But when once we done with the design and development of an algorithm, right? So whether the developed or the designed algorithms are optimized, right? So that is where actually we are supposed to give a thought, especially whenever your algorithm is getting deployed over the real-time analysis, right? So in order to do that, many nature-inspired optimization techniques are available. The most widely used are genetic algorithms, ant colony optimization, and then you have something called the cuckoo search algorithm, right? So particle soup optimization. Right, so you can make use of any optimized techniques available, and you can formulate the mathematical representation to deal with this optimization. Right, so these are the fundamental steps that are available in the digital image processing techniques. I don't really deal with these things, but each and every step have got its own research potential. Right, so each and every step has got its own research potential. Right, so some of the extended applications these are all the fundamental steps. These are the advanced, extended steps are the extended applications that you can work on, like classification, clustering, the extraction, the identification, the detection. For example, somebody said in the very beginning, occlusion, right? So object occlusion, right? So that's a very interesting problem to work on. So occlusion normally, followed by detection. Once you are detect or identify the object, then you can really identify whether that particular object is occluded or not occluded, right? So we have discussed just now the concept of fuzzy, right? So now there is an existence of a fuzzy whether the given object belongs to a class 1 or a class 2. Can it be resolved, right? So that is basically a classification problem, right? So with the labels, but if it is a totally unsupervised or no labels are present, then there would be a problem of clustering, right? So this is how actually you can think of, right? So overall, just to summarize that whatever I discussed, so this is how actually the general real-time image processing techniques looks like, right? So these are all the known data, and you are supposed to create the two sets. One is the training samples and the testing samples. Training set are the testing set, and try to give the mathematical representation here, right? So try to give the mathematical representation here, and you have a projection function here, because why this projection? Dr. Suraj was supposed to discuss in this area, right? So he was supposed to discuss this is an higher dimensional area and this is an lower dimensional area, and you can see the margins that are created in order to categorize the class, right? So for these three laptops, can I pick only one laptop to say that this serves my purpose to identify that class 1 is all about the laptop class, and one bike is more than enough to tell that the second class is all about the bikes, and one cow is more than enough to tell that the class 3 is all about the cow class, right? So that is what actually you were supposed to do, right? So by employing some very interesting dimensionality reduction techniques, starting from PCA and to the present trend that is going on, right? So the present trend is all about the deep learning techniques, which doesn't require any feature engineering techniques, but being a core fundamental researchers, I always advise rather than directly depending upon the deep learning techniques, you try to understand the feature engineering concept and then try to design your own models. So that gives more weightage rather than just deploying by making use of the deep learning architectures. So this is what the feature learning that takes place, and this is where the classifiers that we have designed. So this is an one task that we have designed, right? So similarly, you can segmentation problem, you can the clustering problem, you can fit in identification problem, you can fit in any other problems according to your requirement. Right, so some of the new trends, this is the last slide. So some of the new trends that are going on in the area of the image processing, right? So basically by using, can we think of employing the natural language processing for large-scale medical image analysis using deep learning techniques, because this is exclusively you can see in the field of medical domain. Whenever the doctor writes their prescriptions through handwritten, right? So can you make use of the natural language processing to deal with those prescriptions and then use some deep learning techniques and then does the medical image analysis by giving an appropriate label for that. And then cyber security, yes, this is also another very interesting technique or the domain that you can work on. And you can really think of using the EEG signals and ECG signal based biometric verification, because this is considered to be a very new area where people have not done much work, especially by taking an ECG as a biometric. But we need to really think of what could be the best features out of EEG or the ECG that can be used in order to identify that person is unique. Right, so and then you have smart vehicular communication system. That's what Dr. Nagesh has detected, and stress detection in IT professional by using image processing and image machine learning. Due to this pandemic, many are really facing a lot of stress. Right, so can you make use of some of the basics image processing and machine learning techniques in order to identify or detect those stress? Right, so this is another very interesting area, license plate localization in the unconstrained situation, because we used to see only under the constrained situation, but now people are talking more about the unconstrained situation or the unconstrained environment. Can you come out with the localization of these license plate? And COVID-19, I think it's already been done. I think that yesterday, Dr. Manjunath Aradhya discussed some of the aspects of artificial intelligence deployed to identify the COVID-19, that is through making use of the X-ray images in order to see whether there is a presence of traces of the viruses on the lungs or not. And lastly, agricultural application. This is a very potential area that you can work on, where a lot of computer vision and image processing and pattern recognition things can be applied. Right. So these are some of the new trends that you can really think of. Right. So at last, thank you one and all for the patience listening. And I am extremely sorry for whatever the glitch that was encountered. Right. So that was encountered. I take the responsibility for the technical glitch that was encountered. If any questions are there, you can let me know. I think there is one question.
Thank you, sir. As we all know, we have no control on the natural calamity. Actually, our speaker was from the red alert area, that is Chikmagalur. He tried his level best to come out of that area and to connect to the SFTP, but it was not possible. But we sincerely hope that we have not disappointed you, as sir has overlooked with the research avenues thing. So I wholeheartedly thank Harish sir for managing the show. Thank you, sir. And we have one question with respect. It's from Kumara. Sir, the question I'm not able to understand the question. Actually, he has mentioned with image compression. So you can mail the question to Harish sir. The mail ID will be shared to you, and you can have a word with Harish sir. Coming to the next session, that is we have at 2:30. The link has been shared with you guys. Please be on time. There will will assure you there will be no more technical glitches from our side. And it's at 2:30. The link has been shared. Please be on time. As of now, we'll leave the link. Meet. Thank you.